And we are, hey, it's working, we are live. Okay. First of all, this should say, I made a mistake. This should say exponential functions. I don't know. I got to go back and fix that because we've been doing rational, but we're doing exponential. So exponential functions are really easy. The exponent is the variable. Okay? Exponential functions look either one of two ways. They're either going to look like this, what we call exponential growth. Do you see how it gets steeper and steeper and steeper? And we looked at that the other day, right? This is exponential growth. And then the other can be exponential decay. This was COVID for the last year, right? Hopefully with the vaccine, this is COVID now. Exponential decay. So they come in exponential equations. F of x or y equals a b to the x. So y equals a b to the x. The a is our beginning amount. That's our beginning. Amount. The b is what we call our base. You know, we're doubling, and then we're doubling again, and we're doubling, right? Okay. And then the exponent is sometimes time. Oftentimes, for story problems, it's our time. Okay. So if we've got example 1, f of x is an exponential function, and f of 0 is 3, and f of 2 is 12. So if I do a really quick little sketch of this, it looks something like this. We'd have a point at 0, 3, and a point at 2, 12. And we're told it's exponential, okay? Want me to slow down for a second? I just graph these 2 points. That's all I do, okay? I've got a point at 0, 3, and at 2, 12. Since it's exponential, we know it has to look like this, okay? How am I doing? Am I going too fast? I'm okay, right? We know it has to look like this. So how do we find the equation? Well, first of all, we do know A. A has to be 3. Has to be. But let's plug it in. So one way to do this is that's a x value and that's a y value. So I could go 3 equals, when I put the 3 in for the y, 3 equals A times b to the x power of 0. Okay, so here's what I did. I don't want to confuse anybody, but all I did, every point has an x and a y value, right? I plugged my 0 in for x and my 3 in for y, right? And then to solve this, pretty easy. Anything to the 0 power is always 1. Anything to the 0 power is always the number 1. So really, I get 3 equals a times 1. So, you know, the value of a is 3. But we already knew that. I already knew that because it's the beginning amount. So here's what I know. I've got a y equals 3b to the x power. So I found out what a was. So I put my 3 right there, okay? Now I don't know what b is, but I can do the same thing. I've got another point, some x, some y value, right? So I will plug the second point into this part, because I already have part of it, and I should be able to get b, right? So I put my 3 there, and now I should be able to find b. So, okay, I've got a point 2, 12, 2 is my x value, 12 is my y, so I'll go, okay, 12 equals 3 times b to the 2 power. So I put my 12 here and my 2 there, and now I'm just going to simplify. I'll divide by 3, right? And I'll have 4 equals b squared, and then you should be able to tell me what b is, right? Square root, b's got to be 2, okay? And we will not have negative bases. There's a really important reason for that. Only positive bases, okay? We're going to learn that later, why it has to be positive. First of all, you can see why. Has to be positive base, okay? So b is 2. So now I can write my equation. So my equation is, you ready? Ta-da! It's going to be y, or f of x, equals 3, that's my a, times 2 to the x power, okay? Okay, if you don't hear anything today, hear this. Hear one, everybody listening? Do not make that 6. Do not make that 6. You have to do the exponent first, right? Don't make, that is 3 times 2 to the x power. You have to do that, and we don't know what the x is, okay? Everybody agree with that? Don't make that 6. That would be really bad. Now, could I find f of negative 2? Sure. I've got an equation. I can put my negative 2 in for there. So I can actually find f of negative 2 is 3 times 2 to the negative 2 power. You could use your calculator. That is 1/4 times 3 is 3/4, but me being a math nerd, I know that, and you might not, which is okay because you can just use a calculator. Okay, Mr. Davies, Mr. Smarty Pants, what is 3 times 2 to the negative 2 power? 0.75. Okay, how's that? And you can do that. You don't have to like do it in your head like I did, but you can just use a calculator. Okay. All right. So now, example 2. A bank advertises it can double your money in 12 years. Find fx expresses the function of the annual rate. What is the annual interest rate? Okay, so a bank advertises it can double your money in 12 years. Okay. We need some kind of interest rate. You know, scratch this out and give you enough information. I should have like checked my notes. We need an interest rate. All right, moving on. Let's turn the page. Here we go, half-life. Sorry about that. I need to go back and fix this worksheet. A couple of mistakes. I was in a hurry. Okay, the half-life of a radioactive element is 6 days. In a lab, there's a sample of 100 grams, okay? So half-life is this. Take half of it, half of that, half of that, half of that, right? Currently in Hanford, they've got a lot of really bad stuff. That's going to take thousands of years for it to go away. If you get bored, look up the Bikini Islands. Okay, if you get bored someday, look up the Bikini Islands. Prior to World War II, it was a great place. Bikini Islands, right? It's a great place. But then we had to experiment around with the atomic bomb. We took a whole bunch of our old warships. We dropped the atomic bomb on these warships to see what would happen, right? Nobody can live in Bikini Islands anymore. It's been uninhabited for 50 years because it's radioactive. It glows. Well, it doesn't really glow, but anyway. Yeah. Anyway, get bored, check out the Bikini Islands. Now, let's take a look at y equals ab to the x. That's our exponential function. That's what we had over here, right? We know our base is 1/2. You okay with that? We know our beginning amount is 100. So let's write y equals 100 times 1/2. Now this is a cycle of time. So we're going to go t over 6. Okay? So every day, in 6 days you'll take half of it. Does that make sense? 6 days you'll get half of it. So we have a cycle of time every 6 days. So it's t over 6. Okay, so there's my function. Okay? And if I wanted to, I could write like this. F of t equals 100 1/2 to the t over 6. So if I just wanted to put it in terms of time, I can. Same equation, just in terms of time, okay? Now, there's my exponential function. Now, how much will remain after 20 days? We're just going to put 20 in for t, right? So we're going to go, okay, f of 20 is equal to 100 1/2 to the 20 over 6. Now you're going to need a calculator. And you guys, you can borrow my calculators anytime you want. Maybe you have your own. But I'm just going to type it in. I'm going to go 100 times 1 1/2 to the power of 20 divided by 6. Okay, so I just put it in my calculator. It should be less. You guys agree? Because you're going half of a half of a half. And what do I get? Yeah, about 9.9. Is it grams of this stuff? Yeah, grams. So I've got 9.9 grams of whatever this stuff is. Okay. Probably pretty radioactive if it decays that fast. Okay. All right. Example 4. It looks hard, but it's not. It's easy. Okay. So we have got some stuff, and every 3 hours we kind of check it and see how much is left, right? So what's the half-life? Well, see where my fingers are? It went from 128 to 64. Isn't that half of that? So the half-life is 6 days. Half-life is a time. So the half-life is 6 days.
6 hours.
Thank you. Thank you, Spencer. 6 hours. So every 6 hours, you're left with half. Okay? Write a function model this. Well, we know it's exponential. So we're going to start with, and we know it's half-life, right? So we're going to go y equals our a 1/2 to the t over 6, because it's a 6-hour cycle. What's our beginning amount? 128. So we're going to put our 128 right there. So I'm going to write as an f of t. I like t because it is a time function. 128 1/2 to the t over 6. There's my formula. Okay, we start with 128. Every 6 hours, thanks Spencer. Every 6 hours we have half of it. You okay with my formula? Now, how many bacteria will remain after 1 day? Oh, that says 1. I do need to go back and retype this, don't I? So 1 day is 24 hours. You guys agree? So I'm going to use my formula. I'm going to go f of 24 is equal to 128 1/2 to the 24 over 6. And I'll just use my calculator, right? We'll go to the power of 24 divided by 6. And I get an answer of 8. So it got smaller and smaller and smaller. So 8 is a bacteria. What do you think? Not too bad? Okay, so here's our homework. And how much time do we have? Oh, we got time. Let's work on it together then. How's that sound?